Good day, folks. So, we have a very quick, easy remembering of a topic called memory modes. So, this memory modes is actually related to assembly, language, instruction. Guys, we remember that CPU doesn't understand the high level language. That is nothing but a user, that is human language. The CPU needs an interpretation how it can actually understand the user language. So for that we need set of language that is understood by the computer, and that is said to be the assembly language, where the digital circuit has been formatted, where the digital circuit gets the input in order to do its computation. So in that way, we just remember this memory mode. It's speaking about how the address, how the registers, and this registers is nothing but an address where the data gets stored inside the computer hardware. We do know that computer has its memory where all the data has been stored in the different registers in order for easy retrieval. Because just like that, it cannot be scatteredly stored across, so that the data can be easily retrieved. As we know how the unique register numbers like you guys are having in order for fetching your details easily. The same way we do have a different registers which has been build this particular computer memory, and each register have its own segmentation, fragmentation in order for easy retrieval. In that way, this memory modes, right? So, say for an instance, we do have like AX, BX, CX, DX. So these are the different registers. And again, registers, right? So again, this register is nothing but a memory. The registers are further divided into two modes in each of its kind, like AX into AH and AL, BX into BH and BL, CX into CH and CL, and so on. So this H represent the higher order bits and L represent the lower order bits. So all the four registers, they have their own higher order and lower order bits. It actually divided into immediate, you can say, addressing modes, immediate addressing mode, then direct, then indirect, then a register, then based. So these are the different memory addressing modes. So we just see for an easy example in order to get connect to how it was actually operated. So before that, just have this assembly language instruction. Just it's an instance, right? It's an instance. So move, like we have AL, then consider like 05. We just decode this. So this MOV is nothing but mnemonics. So what is mnemonics? Mnemonics is just a representation to understand. So we can say it's a code, right? So say for instance, if you are pressing Control C, how the computer will understand it. Understand you are asking the CPU to copy the respective content. The same way, this MOV is a one keyword that actually it's a mnemonic that makes the CPU to understand that there was a process that has to be done in order to move. MOVE, it was actually shortly it has been mentioned as MOV. And this AN, you're familiar now, this is a register, and this 05 is a constant, right? So this is how the assembly language instruction would be, right? This actually makes the CPU to do some move. Move what? So we are trying to move, and remember immediate to the mnemonic we have a register, and that will be the destination, right? The next to the destination we have the source. So this is how it will be processing. So now you just interpret with this understanding. So this 05 is the constant, right? This constant is going to move to a register called AL. So this is how the CPU will work. We just go for one more example, like move BR. Now I'm saying CR. So instead of giving the constant, now I'm asking the CPU to fetch the data that has been resided in the register called CR, and that data has to be moved and pasted into the register BR. Right, so now the data will be over here. So now the data will be coming over here. So this a different memory addressing, right? Memory addressing mode. In terms of the assembly language instruction, it was working, right? The CPU understand this, right? So now coming back to the memory addressing mode, first when we told it's immediate, right? So above we have already seen the immediate addressing mode example, that move AL05. So the data is directly moved to the register. This is immediate, right? And now we go for the direct. So direct move, right? We have AR and we have like some address. So consider this is some address, right? This is address. For your understanding, we can make it's in square brace, right? It's an address. Now the data inside this address will be sent to a register AR. This is direct because here we are not giving the data, instead we are giving the address. In the same way around, we have the indirect, where we can say move like AR and BR, right? So now the data inside this register BR will be moved to the AR register. This is indirect. We do have, right, register. So here the address will be given like this. So now the address of the respective destination data will be stored in this register. So this square brace states that this BR register has some address, and this address will be decoded to get some data, and now this data will be moved to a AR. So this is how the register will be done. And finally based addressing mode. This is quite interesting, right? So we do have a mnemonic, we have some register. Now what we are having like the R plus 05. So this actually making the CPU to understand there was some address in the BR. Consider it's like 2000H, whatever, right? Now this has to be added with 05 constant. This finally make 2005H, and this is the address, and this address will be having the data, and that data will be get moved into the AL register. So these are the interesting addressing modes, and assembly language instruction set is understood, interpreted, or perceived by the CPU.